So this is the chapter 1, Basics of GIS, and in this chapter we are going to discuss the introduction, then key components, then types of GIS data, and then we'll discuss something basic GIS functions, and then what are the applications of GIS. So first thing first, that is the introduction to GIS, and in this part the introduction of GIS is that first of all, this is what computer based tools. So we use the tools which are computer based to collect, to store, and then to analyze, and then finally to display what the spatial and geographical data. So it allows us to understand what pattern is there. I mean, the pattern may be the clustered pattern, like few things are clustered here and few things are dispersed here. So it gives us the sense that where the problem is more and where the problem is less, whether the pattern is clustered, random, or dispersed. We can study the relationship also, like if rainfall is higher here, then the vegetation is also higher, and where the rainfall is less, vegetation is also less. How much less or how much more, this can also be studied. Then we can study the trends also, that if we have the data, time series data, then we can use time series data for trend, like from 2000 to 2024, what is the change in the vegetation or moisture. So the important part here is the location. All the data will be, because of this is geographical information system. So without location, we cannot say that this is GIS. So location is important here. And then we come to the key components. So as we know that GIS is a system, and system has a component. So from beginning to end, what we need to do GIS, the first thing we need is the hardware, and we need a computer. We need a server, or we may not need the server also if we are dependent on the data which we have to we need the data, I mean the raster data. So we can fetch the data from any cloud server, web server, or data server. And then if we need some point data or line data or polygon data, either we have in the cloud, or we can, if we need our own generated data, then we should have the GPS devices. Nowadays you see the mobiles are there, so these mobile devices are also having the GPS. So these are the hardware what we need for the I mean for the GIS. The second we need is the software. We may download the software, standalone software we can download in our computer or laptop, and then we can work on it. And also we can work with Google Earth Engine, where there is no need of installation. This is cloud computing. And then we will discuss this Google Earth Engine in detail. As you know that this is chapter 4, which is all about Google Earth Engine, which is a robust platform for data collection, data analysis, and data presentation. And then of course we need the data. We may need the maps, but in GIS the most important is satellite images. These satellite images helps us to collect the data, because as the satellites are collecting much more information, and this information is very useful. I mean, if you look at this one, this is also, I mean, this image is also uh, is a mosaic of many satellite images or satellite slides. So satellite data may be related to the different bands, which we will discuss in detail when the chapter 3 will be there, which is all about the data. And then we may require the census information to attach the, like if we have some point polygon data, then some census information can be attached or linked to that information to do further analysis. And then of course the people who are the people who will use this information, they may be we need the people, we need the experts to do the data analysis, and after the finished data, the finished product may be in the form of the map or maybe in the form of report. So the people, I mean, we are doing for the people, so they can use for the planning or solving any problem. Then there may be a method to do any work, GIS related work, like first you are collecting the data. What type of data is this? If this is raster data, then the method is something different. And if this is vector data, the method is different. So these are the key 5 components of GIS. So it's logical. We need hardware, we need software, we need data, and we need method. And then finally, we need the people to use it. So this is about the key components of GIS. Now, a brief introduction of these types of GIS data. So here the vector data and the raster data. There may be third one, that is attribute, but here just explaining you vector data and the raster data, I mean, which is core classes of GIS data. So what is vector data? As you can see this image here, let me show you this one. So when you see the true color image, I mean the background image you see here, the information is continuous. Okay, so let's discuss first the vector data. Let me make something, a path here. So what is this? This is the line, and this line has some information where I clicked. These are the points, and these points are having latitude and longitude. So the information is discrete. I mean, the only information is this line. This is not continuous for any area. So this is what this is called vector data, which may be a line, and then which may be a point, and then it may be a polygon. It may be a polygon. So this is the vector data. It has its own importance when we do like cadastral mapping, when we do the digitization, when we are digitizing a road, or we are making a point. If we have the GPS data in the form of point, so all this is what? This is vector data. The second is the raster data. Raster data is a continuous data. If we say what is the difference in between vector data and raster data is continuous data. I mean, this is like a image. We take the photograph using our mobile, and the photograph is what is a kind of raster data. And when you see the raster data, when you will zoom in, more zoom in, you will see the pixels like this. So each pixel is having a value. When you will click any pixel, it will give you a value. So this is the value which is calculated into the the GIS based software, whether this is standalone installed in your machine or whether this is cloud computing platform like Google Earth Engine. The next is, what are the basic GIS functions? How GIS works? So how it works? We need to have the data, and this data may be or this may be the vector data. So GIS functions, if we keep aside the problem, what problem we want to study, so it starts from the data collection. If I say that I want to know that how much vegetation has been changed from 2000 to 2024, the first thing we need to collect the data, the satellite data. What satellite detected the vegetation in 2000, and then in 2001, 2002, 3, 4, 5, up to 2024. So that data is required. Okay, so this is what data input. Then you have to take data into your machine, and then how this data will be stored. That is some types of, the maybe a geographic database or something. Data storage, first data, then data storages into your machine, and then it will come to your software, and then you do the analysis, data analysis. So data analysis, there are, 100 types of analysis which you can enjoy. When you have the points, you need to know that, okay, within 100 meter of buffer of this point, how many houses are there. Then you can do the data analysis. That is data analysis. Then you can overlay also, you can buffer also, you can make these spatial queries. If you are interested to know, okay, give me if you have population raster data, and if you are interested to know that where the population density is more than 200% living per square kilometer, you just give this condition, then all data will be removed and you will get the data you need. So similarly, there are many analysis which you can do in GIS. And then after doing analysis, we need to visualize. We can export it as in the form of map or in the form of chart or 3D models. So this is data analysis. Sorry, this is data visualization. After doing your work can be used by the decision makers. So these decision makers may be the policy makers, the lawmakers, which need to know that where the vegetation is declining. So what they need quick action. So unless until they do not have that information produced by a GIS analyst, they cannot say that here vegetation is declining. So GIS is what? This is evidence based. It makes the policies based on the evidence that, okay, GIS data says like this. Or for an example, like if there is some flood and if you need the help, that as many people have been affected because of this flood, there are two ways. You go to the field and you collect the data and you report. The second is you can look at using the satellite data, and it will give you exact, okay, as much area the water was spreaded, and then how many houses were there. So these are the houses, then how many people are affected. Then it will be evidence based information that, oh, look, this is the remote sensing data. So the next part is the applications of GIS. There are many applications, okay, whatever is related to surface of the earth, whether this is geology, this is biology, this is mass communication, this is what natural resource management, this is geography, this is sociology, this is archaeology, this is civil engineering, this is some even architecture also. You need some climate information, and then I think even public health also. They need to know that where disease, what is the disease pattern, where disease outbreak is there, which are the areas where malaria this time will be there. So, and then you can simulate also based on your data, like where you can find these zero dose children's. So all these things are possible with the help of GIS. There are some applications which I want to demonstrate to you, like this is the red area shows that where the vegetation has been declined, and the green area shows that the vegetation is, has been increased. Okay, so this is the way you can look at that where vegetation loss is there, and then you can make some animation also, which will give you better idea. And this is the application in environmental management. Okay, monitoring what? Deforestation, water resources, and biodiversity. Because where the vegetation has been lost, it will impact what? Biodiversity also. Biodiversity is, the wildlife is dependent on what? Vegetation. And then we can use GIS and remote sensing in land use, land cover analysis. How the land use and land cover is changing time to time. What is land use and land cover? Land use, how we are using the land. As a built up area like the urban area or the rural area or some road construction. Okay, all this is what? Built up area. We are using for agriculture, we are using for making the ponds or dams, or so this will be a water class. So land use and land cover is something, land use shows how human beings are using the land, and land cover, what is the natural cover, like a forest area, the desert, and then the grassland area, maybe barren area. So such type of, so in combining both of these is known as land use, land cover. So this can also be studied. How it is possible with GIS and remote sensing? Because remote sensing, the satellites are giving us the satellite images. So we have the satellite images archive. Uh, I mean, if we need to know that how much forest was there in 2010, then we can collect the images of 2010, then 1, 2, 3, 4 up to 2024, and then by making the classification, there are many techniques. We can make the classes of different types of land use, land classes, using the maximum likelihood classification of machine learning, based on machine learning. So this is this work is based on GIS and remote sensing, which in the field of land use and land cover. And then this is the application which I developed this application. This is what? This application gives us that how much rainfall may be there in the coming 72 hours. So how is it possible? How we can do it? Because our satellites can detect the clouds movement, the speed of the cloud movements. Then in the next 72 hours, because clouds, rain needs some conditions, and another conditions can also be detected by the satellites. So combining all these conditions, we can develop a model, and based on that model, we can predict, okay, how much rainfall is there. So I use the data developed by NOAA, which is a US based organization which gives us the data, and here I use this data and classified into 1, 2, 3, 4, 5 categories. Okay, so the fifth category is where the rainfall is above 75 millimeter. So within 72 hours, if rainfall is above 75 mm, what does it indicate? Here, this area, rainfall may be higher. So higher rainfall will bring what? The flood. This is what? Early warning system. So this area should be, I'm making this video today, 28th August, 1:18 p.m. So the forecast is this area, the rainfall may be above 75 mm. So they should be ready for the flood management. And then in the field of public health, we can do disease mapping, we can do the health facility accessibility also. Here this is also an application developed by me. What we can do is we can choose the state here, like the Lagos, or let's see, or we can see here Abuja, and we will select the one LGA, let's say Gogalada, and then I will press button plot. So here this is the malaria prone days. So you will see the monthly from January to December, which month is highest. I mean highest has highest malaria days, and these malaria days are estimated based on the mosquito breeding climatic conditions, like when the temperature is in between this to this, and when rainfall is there, and then wind speed is as much, then if all is suitable, then that will be counted as okay, malaria may be there. But if you see in January, February, March, there is no malaria days, because these days there is no rainfall. So there should be a rainfall here. So this is the way we can predict, okay, here. So this is, I mean, very important for supply chain. I mean, for like how many mosquito nets are required in any area based on the days which are prone to malaria. It varies place to place. And then we can use this GIS and remote sensing for agriculture also, because whatever the components of agriculture are there, like maybe the soil, maybe the rainfall, maybe the moisture, insulation, sunshine, and another many factors are there which can be studied using what? GIS and remote sensing. So here you can see as an example, this is the soil data. We can zoom in any area here, and whatever layer we want. This is derived data. And then if I need to know the organic carbon density here, okay, this is organic carbon density of this place. And then this is 334 blah blah blah. This is something like I mean 100 gram per cube meter. So if we need to download this one, we can also download also, and this will be as an input. Okay, so if soil is suitable, if rainfall is there, and if another infrastructure is available, so you can predict also that this place is suitable for this crop. So for site suitability analysis, this GIS and remote sensing technique is very useful. And then Another interesting thing we can do is we need to know the human development, where the development is going on. So you see at the night there is a night light data, the bulb which we use, street light is there. The light is in the villages, towns, and these bigger towns. So this light is being detected by the satellite, and the satellite give you the images, and then you can see, okay, this is here, this is the light, means there are the human settlement or another human activity is there, maybe a factory, maybe some industry, or maybe a ship. So you can look at the human activities, and where light is more means development is more, and where the light is less means there is less development or less infrastructure. So here this application is developed by me. What I did here is I took 3 time period, 2014, 18 and 2024. So wherever you will click, you will get the information that in 2014, 18 and 2024, that is, and then I assigned the color red, green, blue. Okay, red is assigned to 2014, green is assigned to 2018, and blue is assigned to 2022 image, right? So wherever you see the red color means there was more light in 2014. When you see green means there was more light in 2018, but this light was not as much in 2014 and 2022. That's why this is green. Okay, and blue light will show you that, okay, this is the recent development. Recent development. This is the recent development. So when you see this one as a satellite and you can visualize, okay, this is the area. This area, this is here the new light in 2022. What does it mean? The color is blue means this construction is new and this area was not there in 2018 and 2014. So it will make you study many more things, whether this is human development, this is or site suitability analysis. I want to buy a home where this is newly developed. So you see the light, okay? So GIS can help you in that way also, and you can look at that where the development is more, where is less, and this is the evidence. Your work is evidence based on remote sensing data. You can say that why my area is declining in light electricity, okay? And then the planners can plan, okay, we need to develop this area because here light is less and people are living, and because of less light their activities are being affected. So GIS can help in that way also. And then in flood mapping also, like the flood has been occurred, and then you need to know that how much area is affected. So this application developed by me and using radar data, and radar data is something, because in remote sensing, remember, cloud is a big problem. So sunlight does not penetrate to, I mean, partially penetrate, but the satellite detectors will have a problem to detect if clouds are there. Okay, as far as the optical remote sensing is concerned, which is dependent on sunlight, which is passive remote sensing. But here, when you are studying flood, of course, clouds will be there. So how to study? We can use the radar data. Radar data is, I mean, this active remote sensing is known as active remote sensing. It's not dependent on sun. depends on the microwave energy. So satellite produce the device produce the energy and sent to the earth. So this then that energy when interacts with water, because water surface is smooth, that energy is dispersed and does not bounce back to the detector. So wherever water is there, the values will be very low. So this energy is very useful for detecting the water. Okay. So I use that energy, and we will discuss in detail maybe in chapter 4 how we can do that. So let's see. Let me demonstrate you. Like I know there was a flood in Velsal state, and this flood was in you have to choose two dates here. One date when there is no flood and the date when there is a flood. Then you can compare that how much area water was there as a flood. So let's see, there was a flood I think in August or September. I mean here you have to choose similar month but not similar year. Where there is no flood, maybe 2022, and then you can run the application. So wherever the red color will be there, it's a 3 standard deviation drop. Means 3 standard deviation drop means where yes, so you can see this place here. In this place the red dots indicate that okay, in 2018 this area, this month was not the water, but in 2022 this area water is there. So how much area water is there, how many people affected? So this all possible with the help of GIS and remote sensing. Not only this, everything GIS combine what? Maps with data to provide a powerful tools to analyze real world problems. It helps answer like questions like where is it and why is it there? What if? Okay. So such type of questions, if related to surface of the earth, can be studied very well with the help of GIS and remote sensing techniques. This was the brief introduction of this GIS. Okay, brief introduction to GIS. So in the next chapter, which is the third chapter, we will discuss the remote sensing data. Okay, that is how, I mean, what are the satellite images? What are their characteristics? Unless until you do not know the characteristics, you cannot do analysis. That's why after this we will go for chapter 2. I hope you understood, you got some idea, and if not, please come with your questions into the class. We'll discuss it. Thank you so much.